In the first part of this early warning system, we have learned the basics and community-based early warning system, and also the existing national early warning system available in India. So all the names that we have discussed last time for the avalanches, cyclone, drought, earthquake, epidemics, floods, landslide, tsunami, for all these disasters, which are the agencies that are involved that we have discussed last time. So today we will see that how these agencies they are responsible for giving early warning and related forecasting, etc. So first we will discuss regarding this cyclone early warning system. So the nodal agency which is designated for this cyclone, it is IMD, that is Indian Meteorological Department. And here in India, we are having area cyclone warning centers that are located. So all the critical locations that are more prone to cyclone, like Kolkata, Chennai, Mumbai, Visakhapatnam, Bhubaneswar, and Ahmedabad also. So basically, this cyclone warning process is coordinated by the Office of Deputy Director General of Meteorology, that is related to weather forecasting, as well as Office of Deputy Director General of Cyclone Warning. So both are involved in that. And considering the capability of cyclone warning and the facilities available there, WMO, that is World Meteorological Organization, it is also coordinating regarding this cyclone warning activities globally to standardize the system, because generally the cyclones that are given different names. Okay, so this WMO is also involved in this to standardize the system and also bring any improvement if it is required. So generally, this All India Radio and at the New Delhi, they are provided with the cyclone warning information by Regional Specialized Meteorological Center, New Delhi, for inclusion in the national broadcast. Okay, so basically, this cyclone warning is furnished on a real-time basis. पूरा real-time basis होता है, how the path, etc. At what time the landfall may occur, etc. In the control room of the Ministry of Home Affairs of Government of India, as well as in NDMA. Besides other ministries and other department involved, also the state which is prone to particular cyclone. So here we are having just these are some imageries, satellite imageries that are widely used for this tracking the path of cyclone. So presently, this area cyclone warning center of IMD, it generates special warning bulletins and transmit them every hour in the local language. So whenever such kind of cyclone is going to come, every hour in the local language, such kind of warnings that are distributed through the network of analog receivers installed in the field. But nowadays, this analog receiver, they are trying to replace it with the digital. Okay, so nowadays, in addition to this analog network of receiver distributed in the field, presently these digital stations are also operating along the coast of Andhra Pradesh and Lakshadweep. So this meteorological division, New Delhi, beside this IMD, also use the other conventional method of communication like telephone, then fax, then radio, television for communicating the warnings. So information on cyclone warning is furnished on a real-time basis to the control room set up in the Ministry of Agriculture, Government of India. So this is also involved. So many agencies that are involved, and the dissemination of information is done by various methods. So basically, it is high power cyclone detection radars that are installed along the coastal belt of India, and also the satellite imageries received from the weather satellites. They are used in detecting the development and movement of the tropical cyclone. So both they are using these radars as well as satellite imageries. So this digital cyclone warning center is developed by Space Application Center, ISRO. So here one digital cyclone warning system is developed, which is DTH based cyclone warning and dissemination station. So many agencies that are involved, but the ultimate agency, nodal agency is IMD. So here we are having existing 4-stage warning system for the cyclone. So that was introduced in IMD from pre-monsoon season of 1999. Earlier it was 2-stage warning, but then after now we are having 4-stage warning system. Okay, so it is done in stage-wise manner. So first special bulletin, which is called as the pre-cyclone watch. Okay, so first is pre-cyclone watch. It is issued containing the early potential indication. कुछ indication आया due to the development of some cyclonic disturbance in the particular region, and it may be having possibility to develop it into the cyclone or to convert it into adverse weather. Okay, so pre-cyclone watch is to be issued, and additional warning if it is required, that is with respect to fisheries and ports, that are also issued. So depending upon the activities, pre-cyclone watch is first given. At the second stage, cyclone alert message. So if it is confirmed, that confirmed तो नहीं, but उनको ऐसा लगता है कि still it is going on. So this cyclone alert message is issued 48 hours prior to the expected time of commencement of adverse weather over the specific coastal area. So first pre-cyclone watch, depending upon the situation. Second, cyclone alert message. Then third is cyclone warning. So that is issued 24 आवर्स इन एडवांस ऑफ द साइक्लोन्स लैंडफॉल. जहाँ पे भी होने वाला लैंडफॉल, उसके 24 आवर्स पहले साइक्लोन वार्निंग दिया जाता है. ठीक है. एंड द फाइनली आउटलुक विच इज इश्यूड 12 आवर्स बिफोर द लैंडफॉल, and this outlook notice, it is continues till such time time of as the cyclone force the gusty winds, means जब तक वो चल रहा है, and it may prevail for the longer time over the entire region. So जब तक वो खत्म नहीं हो जाता तब तक this outlook notice issues outlook, which is depending upon the this landfall and whatever the situation related to this wind situation, and whatever situation the vulnerability of area or the high risk zone area that can be used. So IMD is again the nodal agency for monitoring all the earthquakes. So India is at a risk and vulnerability of about 59% of the land area that are liable for the moderate to severe earthquake. And during the period of 1990 to 2006, we have observed 6 major earthquakes in India. So all the seismic activities in India, that is generally monitored by this IMD. So generally this IMD, they are maintaining a countrywide network of seismological observatories, okay, for the regional seismic monitoring in India. So they are having this seismological observatories, and it also operates on the VSAT based digital seismic telemetry system around Delhi for close monitoring on seismic activity in the region. And IMD is presently in the process of upgrading its network of observatories by adding new stations and upgrading the existing stations. So continuously they are improving their observatories, and that are involved in continuous monitoring of all the seismic activity in the various region of India, which are more liable to earthquake prone region, you can say. So they will record the occurrence of earthquake anywhere in the country and report the same to the various designated functionaries in the government of India and the state government. जो भी उन्होंने observation दिया है, they are supplying them to that respective agencies and at the all India level as well as at the state level. So all these data which are collected over the long period of time, that can be used for protective hazard risk and HRV analysis के लिए normally use होता है. And based on that analysis only, we could get such kind of this earthquake prone region, that is zone 4, zone 3, zone 1, like that. So high risk zone, moderate risk zone, low risk zone, that can be designated. And once you are having such kind of hazard risk and vulnerability analysis, then you can try it for the mitigation effort. So all the structural and non-structural effort that can be taken up, mitigation effort to minimize the impact of earthquake. So this IMD, through its seismological observation, they are very useful in maintaining all the records, and that is useful for HRV mapping, and that can be useful for the mitigation effort. Now next is flood. So for flood, so every year in India, we are observing one or other region, the flood is coming. Okay, so the CWC, that is Central Water Commission, they are having very important role in flood forecasting. It's not only the rainfall; it is the flood forecasting. So here, many efforts are required because we have to first collect the data, then you have to process it, you have to modify it, then you have to use the hydrodynamic model and mathematical model to forecast कि भाई इतना rainfall आए तो कितना flood आ सकता है. So it's a long process. Okay, so basically there are first step is data collection. So basically there are two types of data which are generally useful. First is real time hydrological data. So when we are talking about the hydrological data, then we have to collect the data that is related to your gauge, that is level, and second is discharge, kitna pani aa sakta hai, flow, and second is meteorological data, so that is hawaman related, so that is rainfall data. Okay, so these data are the basic requirement for formulation of flood forecasting. So generally, who will collect this data? So this data are collected by the hydrological observations stations on major river. Okay, and level forecasting stations on main river, and inflow forecasting कितना पानी आ रहा है, level forecasting station जो होते हैं on the main river, that are to be that are used for the collection of data. So that covers major 9 major rivers and 65 major sub basins. So which are flood prone. So where you have to locate all this. Okay, so these data are collected daily and analyzed and utilized for the formulation of the flood forecast given 12 to 48 hours in advance. Okay, so they have to give this data 12 to 48 hours in advance before you are giving the flood forecasting. So data are collected by the flood formations, this field formations by CWC, BIS and FMO, that is Flood Meteorological Office, and IMD, by what they are doing, they are supplying the daily rainfall data using this rain gauge and situation including heavy rainfall warning. So first thing, data collection, hydrological data and meteorological data. Next is transmission of data to flood forecasting center. So flood forecasting center जो होते हैं CWC में होते हैं, that is Central Water Commission. So all this data, transmission of the data on the real-time basis, that is hydrological and hydrometeorological station to the flood forecasting center. It is a vital factor in flood forecasting system, transformation of data. Okay, so there are over 500 wireless station of CWC all over the country for communication of this रियल टाइम डेटा रिलेटेड टू फ्लड फोरकास्ट. तो फ्लड फोरकास्ट के रिलेटेड जितने भी डेटा है सब CWC को ट्रांसफर किए जाते हैं. ठीक है, ड्यूरिंग द फ्लड सीजन द डेटा इज कम्युनिकेटेड 2 to 3 times a day. Okay, and the frequency of transmission may be increased up to the hourly basis. अगर बहुत ही ज़्यादा कंडीशन वर्स्ट होती जा रही है, on the hourly basis also the data may be transferred. Okay, if the flood situation is demanding such thing. So CWC is maintaining a reliable and quick system of data transmission. So data collection हो गया, hydrological and meteorological. Second उसका transmission हो गया. Now third stage is data processing and formulation of forecast. So this is the main thing, that is formulation of forecast. जो भी data available है उसका अभी आपको use करना है forecasting के लिए. So all these data, gauge, discharge, rainfall, they are utilized for the development of the techniques for formulation of the forecast on a real time basis. वो भी time basis कि कितने टाइम पे कितना फ्लड आ सकता है. So this forecast are formulated at the flood forecasting stations by predicting river gauge inflow within the time. वो predict करते हैं कि river में कितना पानी आ सकता है. ठीक है, after receiving the data that is based on the field observations, क्योंकि उनके पास field observations भी होते हैं, the data is processed in the flood forecasting room, and that data may be modified अगर उनको लगे कि there is some inconsistency in the data, so they are just modifying it अगर accurately नहीं है. So that can be used for flood formulation now. So computer based comprehensive catchment scale hydrological and hydrodynamic models interfaced with the flood plain inundation means कितना flood plain inundation means कितना पानी में जा सकता है. Mapping tools are generally developed, and this computer based watershed Mike 11 ये एक सॉफ्टवेयर है दैट इज यूज्ड बाय द CWC is being used for the inflow forecast. So कितना inflow आ सकता है, so that is generally formulated. So forecasting can be done. Okay, so this forecasting obtained from this mathematical model or computerized watershed models, they are generally modified if required to obtain the final forecast based on the heavy rainfall warning by IMD. So where they are issuing this forecasting, so whenever river stage at the flood forecasting site exceeds or likely to exceed a specified level called the warning level of the site, which is fixed in consultation with the concerned state government. Okay, so they have to consult with the state government के warning level कितना रखना है. So flood forecasting site they know that this much may be the height. Okay, so the warning level is generally 1 meter below the danger level of the site. Although there is no common format for issuing such kind of flood forecast, but normally जितना भी आपका danger level है उससे 1 meter below, if you are having that forecasting related to this flood, then warning can be given. Okay, so in the forecasting, the current date and time of issue of the forecast, present water level जो अभी है, and anticipated water level with corresponding date and time are generally included. Okay, so already based on that mathematical and computerized model, based on the data, they have given that flood forecasting. Now next is to disseminate the information. So the final forecast are then communicated to the user agencies such as concerned administrative and engineering authorities of the state and central governments, including railway, defense, other agencies connected with the flood protection and disaster management by SMS, telegram, wireless. So these are all the mode by which the communication can be done. And this flood forecast are also passed on to this All India Radio and Doordarshan and the local newspaper. Okay, so to disseminate the information to the publicly in the affected area. So this way, in the 4 stages, the flood forecasting can be done. First is data collection, second is transmission of the data, third is data processing and flood forecasting, and fourth is dissemination of the flood forecasting and warning. Next is tsunami. So many times I've told you that the Indian Ocean tsunami of 26th December 2004, it was so devastating that it has just ruined the coastal community of 14 countries, and it has resulted in the enormous loss of life and property. Why? Because there was no tsunami warning center in India. Early warning system India में नहीं था before 2004. So this tsunami preparedness provide the tsunami early warning system for the issue of early warning messages and dissemination of such messages to the coastal community. So regional tsunami warning center was set up in Indian National Center for Ocean Information Services, Hyderabad, and is operational since 2007. Okay. So as a part of early warning system for tsunamis and storm surge in Indian Ocean, it is set up by the government of India 17 station which are real time seismic monitoring network established. So first इसमें सबसे ज़्यादा चीज़ है, first is आपको पहले तो detect करना है, ठीक है, earthquake which has capability to convert it into tsunami. So this Indian Ocean, in Indian Ocean, 17 station real time seismic monitoring network that was established. तो सिस्मोलॉजिकल ऑब्जर्वेशन इज एसेंशियल, तो फर्स्ट वो एस्टेब्लिश कर दिए. ओके, सो दिस नेटवर्क इज डिजाइन टू मॉनिटर एंड रिपोर्ट द अकरेंस ऑफ द अर्थक्वेक कैपेबल ऑफ जनरेटिंग सुनामी, and that is nearby area of Java, Sumatra and the North Arabian Sea area in the least possible time. So first you have to detect earthquake. This central receiving stations located at IMD New Delhi and INCOIS Hyderabad receive 24/7 real-time seismic data. So ये जो earthquake के data है that are available. So first one from the network जो हमने already established किया of IMD. Apart from that, they are also receiving data from other agencies. So that is International Seismic Network of Japan Meteorological Network. So they are also supplying the data. You are having your own data that is by our own seismic stations. Second, from Japan Meteorological Network. Third is Pacific Tsunami Warning Center provided in the Indian ocean countries, they are also providing the information, that is earthquake information, epicenter, magnitude, general statement about the potential for the tsunami generation, and estimated arrival time of the initial waves. So this specific tsunami warning center से भी जो data आते हैं, that are also combined together. So this global seismographic network of 200 active stations belonging to the Incorporated Research Institute of Seismology, USA. It can detect all the earthquake with magnitude greater than 6 in the Indian Ocean within 8 to 15 minutes of the occurrence. So it's not like only that seismological observation center set up by IMD we are using. We are also using this Japan Meteorological Network as well as specific tsunami warning center जो data provide करता है. Based on that, the tsunami warning can be given. So this Indian tsunami early warning system comprises of, so early first data, that is seismic station, real time network of seismic station, so that will give you earthquake related. Now after that, bottom pressure recorder, so this is very important part. And third is tide gauge, because this bottom pressure recorder, they are very essential to measure at the bottom. So once earthquake is developed, next is bottom pressure recorder is important, and third one is tide gauge. Okay, what will be the probable height of that particular tides which are going to be generated, because that is actually responsible for the tsunami. So generally, this land-based seismic station, they are detecting the earthquake. Okay, in the this tsunami genic zones of this Java, Sumatra, and North Arabian Sea. So first, this will be detected. Detection of the tsunami generation is done using this network of 10 to 12, 10 that is bottom pressure recorder. So here we are having the bottom pressure recorder that will be responsible for measuring the change in water level of 1 centimeter at the water depth, and that is up to 6 kilometer of water. So basically that DART system that is used, and monitoring the process of tsunami and storm surge through a network of 50 real-time tide gauges. So here these are the typical location of this tide हो सकता है. Okay, so first earthquake, second is bottom pressure recorder that will measure the change in water level, and third is storm surge, means how much tide that will be developed. So this tsunami modeling that is used, and addressing the inundation and the amplification of all along the coast and island. So basically this DART system that is used, and here these are the locations of the bottom pressure recorder. Okay, so these are the location of the deep ocean bottom pressure recorder, 10 in Bay of Bengal and 2 in the Arabian Sea. Here there are 2, and here there are 10. So all these combinations, so this bottom pressure recorder, some changes are observed depending upon the earthquake magnitude. And here it is connected with the surface buoys, that is connected with the GPS. So at the time of application of GPS, we have discussed this DART system, and that is transferred through this satellite system, and that will reach to your ground station. Okay, so that way the tsunami that detection can be done. So it generates and updates the high resolution data based on bathymetry and coastal topography, coastal land use, and coastal vulnerability, as well as the historical data based on the tsunami and storm surge. So many other data that are generally used to prepare and update the storm surge. So what is storm surge? So here just see, this is your normal high tide. Okay, and when at the time of tsunami, this storm tide may be 17 feet, so you can say this storm surge is 17 minus 2, that is 15. Okay, so this storm surge or tsunami hazard map, that is generally at the scale of 1 is to 5000 scale, that can be generated, and that is for the coastal area of 1 to 3 kilometer, and for 10 to 25 kilometer at selected area near the coastal water bodies can be generated. So if the storm surge कितना high tide आ सकता है, so that can warn the people. So and you can use that data to for the evacuation of the people and to shift them to a safer place. So this way, by using seismic data, then bottom pressure recorder, then this particular there's buoys that are connected with the GPS, and all this modeling, etc., and other data that are generally used for tsunami warning. So this tsunami warning operates using 3 tiers. So basically watch, alert and warning depending upon the size and continuity of the waves detected. So for area which is closer to earthquake source, warning is given. जो भी नजदीक है उसको warning दी जाती है, and that is given within 5 to 10 minutes. जैसे earthquake आया, warning would be issued. For far area which are far away, watch signal. So उनके लिए watch signal is generated, and if required, warning is issued based on the bottom pressure recorders as well as tidal gauge signals. Otherwise, if it is within limit and there is no such kind of emergency or risk, then in that case, the watch signal can be cancelled. Okay, 5 coastal observation radars and 2 current meter moorings. They are also installed to monitor the storm surge and physical behavior of the ocean. And software necessary for continuous monitoring of the seismic and sea level change data is developed by this INCOIS in collaboration with National Institute of Ocean Technology and TCS. So basically, जो software जो actually which is used for the warning, that is warning center of India, which is used for the generation and timely advisory by this INCOIS in collaboration, issues the confirmed alert. Okay, so the confirmed alert can be given within 30 minutes of earthquake. So 30 minutes of the earthquake, this is the time that can give the confirmed alert related to tsunami. Okay, tsunami-genic zones, then real-time tide gauge, under ocean surface and meteorological observations वो भी use करते हैं, thermal monitoring station, then bathymetry, historic data, all other topography vulnerability, and that through data communication system that we transfer to this tsunami warning. So they are using modeling for this to give the warning related to tsunami and storm surge, and ultimately the warning would be issued. So this is just the summary how this early warning system is working. Next is drought. Basically, this incorporate the very so many data are involved. Basically, climate, soil, water supply factors such as precipitation, कितनी बारिश हो रही है, कितना temperature है, soil moisture conditions, snowpack, then reservoir, lake level, groundwater level. So many data that are involved. So basically, this drought assessment is based on the comparative evaluation of the satellite observations that will give you idea about the green vegetation cover. Okay, so based on this satellite imageries, you can observe this green cover in a particular district for a specific time period. So near real-time assessment of the agricultural drought at district level for the state and sub-district level for the states, that is decided in terms of prevalence, severity, and persistent during the Kharif season, and submission of the monthly drought report to the Ministry of Agriculture and State Department of Agriculture and Relief of different states. So they have to continuously provide the data. Now here there are certain issues regarding this drought warning, that is related to time of declaration, कि कब आपको declare करना है. So there are different criteria in different states. There is no uniformity, and they are having differences in time of declaration from state to state. अगर suppose if early declaration कर दिया आपने जून जुलाई में, and if suppose there is a improved rainfall later on, so we cannot accommodate this June July data. But if drought declaration, if you are doing at the end of the season, so it is too late for the relief work because already आपका drought condition आ चुका है. So this differences in the line of the declaration that are generally there whenever this early warning related to drought is there, but that varies from state to state. Now, after knowing this early warning system, also you should know about that communication. So that are very general common communication modes that are available for early warning system and forecasting. So sometimes in examination, it may be asked as a separate question also, which are the different communication modes available for early warning and forecasting. So these are radio and television. So these are very common, you can say, communication modes. Then fixed and mobile telephones, then short message services, SMS, Darshan, ham radio, they are also providing facilities for the early warning system and communicating the alert messages. So one by one, we will see how they are helping in disseminating the information. So whenever you are having early warning system, this early warning system can only be effective in saving the life of the people when it is communicated to people who are going to be affected. If they are not knowing, then there is no meaning of such development of early warning system. So this is the main part, that is communication. So here we will discuss this various communication modes, very simple communication modes for disaster forecasting and early warning. So this NDCN, that is National Disaster Communication Network, use various technological options during the phase of disaster management, and some options which are more effective than the rest depending upon the nature of the disaster, the region affected, and the socio-economic status of the affected communities. So various modes are available, they are using depending upon the situation. So first and very important and very common, that is radio and television. So always you can see radio and television, they are giving such kind of information. So this is the most traditional electronic media used for disaster warning. The effectiveness of radio and television media is very high because they can be used to spread a warning quickly in any easily as well as understandable and local language, because हर जगह का अपना खुद का चैनल भी होता है, and in the local language that can be given to the large population even if the tele density is relatively low. So because this television and radio, they are operating and they are available in most of the areas, so they are very effective. But what are drawbacks? Effectiveness is significantly reduced at night. अभी नाइट में 2 बजे कुछ हुआ, so at that time they are switched off. So there is no meaning of this. So after this Indian Ocean tsunami of 2004, many radio manufacturers, they are considering to introduce a new digital radio alert system that would trigger even when the set is switched off. Okay, and particularly in the region which is prone to such condition. So in order to activate that alarm, a special signal sent through a terrestrial transmitter or a satellite that would be used to automatically tune it to the emergency broadcast channel. तो अपने आप वो broadcast channel रात में भी चालू हो जाएगा, because in the very midnight people are not using this radio and television, so at that time it may automatically start, and that is the emergency broadcast channel, so that people would come to know that some warning is going to come, so they can save their life. So that is no common one, that is radio and television. Next is telephone. So this telephone is also very common, okay, but to reach through telephone to each and every person, it is difficult, okay. So it is also playing very important role in sending early warning to communities, but how it can be useful, that we will discuss. So here one example is given: a timely telephone call from a person. He was belonging to Nalavada village in Pondicherry, who was at the time that tsunami came working in Singapore, but he came to know that कि भाई कुछ होने वाला है, because इंडिया में तो वार्निंग सेंटर था ही नहीं. So he warned the people and he could save the people around 3600 of that particular village as well as 3 neighboring village just by this simple phone call before the tsunami hit the particular coastal region. So this effectiveness of telephone call can be enhanced by the mechanism which is called as the telephone tree to warn the communities of impending dangers. So basically in the such disaster prone region, this telephone tree can be developed. So it's a systematic manner in which the message will be transferred. So when an individual receives a warning message, either through phone call or by any means, he or she is supposed to make a predetermined number of phone calls. आपको पता है कि मुझे ये 2 लोगों को फोन करना है, okay, and usually 4 to 5 people, okay. to other in the pre-prepared list. So already you are having list कि मुझे 4 लोगों को phone करना है या 5 लोगों को phone करना है, and this arrangement not only ensures that timely delivery of the warning message, but also it will avoid the duplication of the effort. But what are drawback? Generally, this penetration of this telephone in the rural and coastal area is far from satisfactory. That is the first reason. Also, this congestion of the telephone line that may take place generally during or before the disaster. So that may result in many phone calls in that vital period not being materialized through. So that may be the drawback. But through this telephone trick, the effectiveness of this telephone that is fixed or mobile that can be increased. Now next is SMS or cell broadcasting short message services. So it permits the sending of short message between the mobile phone, other handheld device, and other landline telephones. So this SMS work on the different channel and that can be sent or received even when phone lines are congested. अगर phone line congested है तो भी आप SMS भेज सकते हो. Okay, and SMS has also another advantage that it can be sent to the group simultaneously. So this cell broadcasting feature through which the public warning message in text form that can be sent to the many people, okay, ranging from one single cell to whole country also. So this cell broadcasting system is very effective, and also there are advantages in cell broadcasting during the emergency purpose because no additional cost to implement the cell broadcasting. Also, no need to build any new tower or no need to go for any separate cable or no need to write down any software or replace handset, and also not affected by the traffic load, and that is very useful during disaster when there is a network which is crashed. And also this cell broadcasting is geoscalable, so message can reach to hundreds or millions of people across the countries within a minute. So this is a very effective method, and nowadays government they are also using this cell broadcasting system for transferring their messages to people. Next is internet, and that is through email. So basically, this internet now it is globally available, and that is widely used. Okay, so that can be useful for this communication system. So which is very rapid and very cost effective means which can be useful for national international disaster warning communication. Okay, the internet while broadly available has no timeline guarantee and it is subjected to congestion and disruption. The role of internet, email, and instant messages can play in disaster warning entirely depend on their penetration. अभी कितने लोगों के पास net available है, depending upon that, that message can be reached. Okay, so there's email, internet that is widely used nowadays, WhatsApp, but that systematic grouping is essential. Then intranet and virtual private network. So basically, intranet is a segregated community of network which is strictly controlled, having controlled access and particularly managed by a single organization. So it is protected by password, security, firewalls, etc. So it is a virtual private network. So since users are all from one entity, large traffic peaks can be identified and controlled are more easy and messages can flow without the fear of congestion. So this is for the special that particular organization or that single community only. Next is amateur radio, which is also called as the ham radio. Okay, so this is also widely used. So this is a reliable communication to the disaster relief organization, especially when traditional communication infrastructure break down. Generally, the during this Indian Ocean tsunami, when all the electricity and communication system infrastructure that was destroyed, Andaman Nicobar Island, this amateur radio that have played a very important role, and that has just these operators were the critical link between the island and Indian mainland and help in coordination of rescue and relief. So that was the power of that amateur or ham radio. So some amateur radio that operates and that are generally useful for the voice message, but some of them are also useful for digital mode also. And these radio broadcasters they are authorized to communicate to different frequency, high frequency, very high frequency, ultra high frequency, and even satellite bands on the radio satellite bands of the radio station. This high frequency waves that can travel long distance, but this VHF and there's UHF that can travel to short distance, but they can also very helpful in communication. Next is community radio. So this can also be used. So even though there are not many cases where community radio has been successfully used for the disaster warning purpose, but still it is a medium that can be very effectively used in disaster warning purpose. And the effectiveness of this medium is being established through a disaster warning system implemented by INCOIS. Also, you can use these sirens. Though it is not a information communication technology related, but they can also be very useful. So one example I will give you the impact of early warning system in our neighboring Bangladesh. In early 1970s, a cyclone killed so many people, more than 3 lakhs. But when this early warning system that was operated, only the lives that were lost around 3,000 during the cyclone, similar cyclone. So these are the references that I have used, so that these are all, and also the guidelines of NDMA. So thank you very much. So I hope that whatever contents which I have shared, that is very useful to you in understanding your disaster as well as this early warning system. So thank you very much.